for each of you. I think there might even be enough for one for every 2 people, at least 1 per table, right? Okay? So what you are going to do is exactly what I'm about to do. You're going to present protein synthesis to me, just very, very basic protein synthesis. And that's going to be a small summative quiz grade. You could do it today if you feel ready. You can do it Monday if you feel ready. Okay? All right, so we have the players here. First of all, we have a nuclear membrane, which you're going to use to divide on your table the nucleus from the cytoplasm. Okay? So in the nucleus, we have the DNA molecule. So I don't have an RNA polymerase model, but just kind of imagine that the RNA polymerase is going to unzip it. And that one side of the DNA is the template side that's actually going to be used to make the messenger RNA. So this is already, your RNA molecule is already taped together for you in your kits, and that's fine. And what happens is the RNA polymerase is going to put all of the matching complementary RNA nucleotides and use the template as a basis for putting messenger RNA together. That's called transcription. So once you have a messenger RNA transcript that's completed, the DNA goes back together because only a small part of the DNA opens, actually, just the part that has the gene in it. And when you have the gene transcript, this is going to travel through the nuclear membrane and out into the cytoplasm to find the ribosome surface. The ribosome surface, which to a little messenger RNA kind of almost looks like a planetary surface. And I'm going to put my messenger RNA just like this so that its pieces are pointing outward. So out here, you have transfer RNA molecules. And each transfer RNA molecule attaches to a specific amino acid. So this particular one fits here. And this is phenylalanine. A lot of them end with "ene," amino acids. And the transfer RNA has an anticodon at the bottom. This particular one is AAA. That's the anticodon. And then it's going to be searching for the codons that are going to be here on the messenger RNA, right? It's only going to match up if the codons are complementary. So I'm just going to finish connecting these here. There we go. So all right, so the first codon that we need to match is AAU. That's the codon. The anticodon that matches that is UUA. So here comes the transfer RNA molecule, and it's going to attach itself there and wait. Okay. The next one we need, the codon that we need is GCU. So we're looking for the anticodon that goes with that. And I think it's going to be, yes, AGC, I think is the right one. So here comes this, and this is an arginine. And look how close it brings those amino acids together. So that brings it close enough that it's not too difficult for a new peptide bond to form between them, and now you have the first bond. This transfer RNA goes away to find another phenylalanine. And the last one that comes in has to match codon UUU, and the codon will be AA. The anticodon is AAA. So here it comes. Again, placing the 2 amino acids, phenylalanine and arginine, very close together so that a new peptide bond can form. This one goes away. And this would just keep going and going and going. It would be a much longer. There's not very many polypeptides in the universe that are only 3 amino acids long. Shortest polypeptide ever. But that's what you're going to show me, right? The formation of this polypeptide. This was translation. Translation happens in the cytoplasm and at the ribosome. And it is the translation of the codons into a polypeptide chain, depending on matching of the anticodons on the transfer molecules to the codons on the messenger RNA. And that is protein synthesis, and I hope that was helpful.